Okay.
Okay, this is the circuit that we built. So what we have here is the Wheatstone bridge in the circuit. So we have the 3 known resistors, and then RS, which we're trying to figure out, and then the potentiometer here. And so we have our 2 channels connected to each side of the bridge. And what we have here running is the wave gen is giving it a sine wave, and our scope is measuring each of the channels, which are in yellow and blue. And then the red is the difference between the 2.
These are in kiloohms, right?
The C1 minus C2.
2.21.
So when I change the resistance of this potentiometer, then that's changing the ratio of the resistors on each side of the bridge, so that then you can see the difference between the 2 is going closer and closer to 0 until we have it at 0. And we can zoom in on this and see that there's still some deviation. Oops, I dropped it. But it's okay. So we're gonna keep changing this. Maybe zoom in one last time. Try to get this as close to 0 as possible. So that's about as close as we're gonna get. And so now, this peak-to-peak voltage, we can see is just like 17 or 18 millivolts is the difference between those peaks. And the reason we're trying to find the minimum value is so that we can use that equation that we derived in class in order to find RS as a function of the ratio between the other resistors in the Wheatstone bridge. So now we can find RS.